What's up, good people? This is section 2.3, equations of linear functions, and there's a couple of forms that I want to show you. These are all linear forms, and these are all formulas we got to have eventually memorized, and that's fine if you don't have them memorized yet. But by the time we practice it and use them and turn them over and over and over again, eventually memorize them, then will be a lot easier because you've used them so much. Standard form looks like this: ax plus by equals c. Notice that all three of these forms have both an x and a y in them. So if you're graphing them, it would look like 3x plus 4y equals 12 or something like that. And depending on the textbook that we use, standard form often will have no decimals or fractions as part of the requirement. So like a and b and c have got to all be just whole numbers. So no, it would never be 2.4x plus 2.5y is equal to 3.6. You'd have to multiply all the terms on both sides by 10 to clear the decimal, and that would be standard form. Slope-intercept form is y equals mx plus b, everyone's favorite. Point-slope form would be y minus a number like y1 is equal to a number slope times x, the variable, minus another number x1. And point-slope form, x1 and y1 are actually a point, a location on the graph. M is a slope. And what is slope? Definition of slope is technically m is equal to y2 minus y1 over x2 minus x1. So I hope these are not the first time you're seeing it. I hope it's more of a refresher. Maybe your Algebra 1 teacher showed you, or maybe your course readiness talked about this. So anyway, let's take a look. Example 1, write y equals 2/5 x plus 14 in standard form. It looks like this. So you can, standard form has got to have just a number on the right-hand side with some number x plus some number y on the left-hand side. So we got to move the 2/5 x over to the other side. First step, I think, would be to clear the fraction. Honestly, anytime you can clear a fraction or clear a decimal, just the problem gets way easier to think about. So let's multiply all the terms on both sides by 5. Why do that? So we can clear out the denominator here. Y times 5 is 5y. 14 times y is 70. And 2/5 times 5, 2/5 times 5 is, you can change it to 5 over 1 if you'd like, and it turns into just 2. So that means that this would be 2x. Fraction cleared, way easier. Let's subtract 2x from both sides, and we get this, negative 2x plus 5y equals 70. Awesome. Let's take a look at example 2. Write 12x minus 4y equals 24. Note that standard form and put it back into slope-intercept form, kind of the reverse process. Well, slope-intercept form has to have y all by itself, so let's take this, and I think one change. Honestly, subtraction just confuses people all the time, so sometimes it's just a lot easier to rewrite things in terms of addition. And if we do that, if you're going to change the subtraction to addition, you need to make the second term negative. So this becomes 12x plus negative 4y is equal to 24. And now you can see it's a lot easier to see that when you subtract 12x, you get this, and then you have negative 4y is equal to 24 minus 12x. All right, now we got to undo the multiplication. Oh, a common mistake on this, like if you don't change it to addition, the common mistake is to say, oh, I have to add 12x to both sides because I'm undoing the subtraction. No, you can't add 12x to both sides and expect this to cancel out because this is positive. And it's a lot easier to see when it's addition. So that's why we subtract 12x from both sides. Now, going to the next step, we can divide all the terms on both sides by negative 4. Why? It's to undo this multiplication. It's in between the negative 4 and the y. So negative 4y divided by negative 4 is y. 24 divided by negative 4 is negative 6. And negative 12 divided by 4, negative 12x divided by negative 4 gives you positive 3x. And technically, this is not really in standard form, in slope-intercept form. I think what I want to do is actually rewrite this in slope-intercept form. So that would be positive 3x minus 6. That would be the finished version, because now we have y equals mx plus b. Technically, you could say it's plus negative 6 if you really wanted to. All right, next, example 3. Shoes. The equation 3,246x minus 2y equals that big number can be used to estimate shoes sales in Europe from 2010 to 2015, where x is the number of years after 2010. So if x equals 0, that means 2010. If x equals 1, that means the year 2011. If x equals 5, that means the year 2015. Y is the revenue in millions of dollars. What is the equation in slope-intercept form? What do the slope and y-intercept represent? Okay, so let's just move it around. We've got this here. We'll copy the question right here, copy the equation, and I'm going to change the subtraction to addition so that now it's a bit clearer to see that you can subtract this term from both sides. We get this. Negative 3,246x. Boom. Now I'm going to divide all the terms on both sides by -2, and so we get this. What do the slope and y-intercept mean? Well, the slope means you're going to get this many dollars per year. So, and it's a little bit easier to see what the units are. It's always important to examine units. The slope is going to be the y units per the x units. So y is revenue in millions of dollars. So that would be sales. Let's type in millions. Millions of sales. So like 1,623 million sales per year. And the y-intercept would be the starting revenue in 2010, also in millions. Okay. Now would be a good time for the audio check. So I just want to let you know that I've run one marathon in my life, and that was a lot of fun. It was also really painful and took a long time to train for. I'm the black sheep in my family. It's only run one marathon. Everyone else has run multiple marathons, but I'm like, okay, one and done. Peace out. There's your audio check. Example 4, smartphones in 2013. There were 1.31 billion smartphone users worldwide. And by 2017, there were 2.38 billion smartphone users. Write an equation to estimate the number of users in 2025. That's in the future. So unknowns. We have to clearly define what we know and what we don't know. What we know, the unknowns can be x, because in the previous problem it said what x and y were going to be, but now that's left up to us. And almost very often, time is going to be the x variable. Sometimes you'll see some instances where it's not, but if you are trying to find something per year, then x is, or something per minute or something per second, or whatever it is, then x is going to be the variable that represents time, and that's going to be years since 2013. It's you could just say like x is equal to, like, the first x value would be 2013 and the next x value would be 2017, but this simplifies the math a whole lot if you just say years since and then call this your starting year. Way easier to graph, way easier to calculate. Just the studentship gets a lot easier. So years since 2013. And then the y variable is going to be represent billion of smartphone users. So the knowns turn into in 2013, 0 is representing 2013 because that's years. There are 0 years since 2013 in the year 2013. So we know that in 2013 there were 1.31, and then 4 years later, in 2017, there were 2.38. And so what we want to find out is, let's see, 2025 minus 2013. That's 12 years after this whole thing starts. We want to know how many smartphone users there are. All right, rock and roll. So let's use our definition of slope to find out what the slope is. This is going to be y2, this is going to be y1, x2, x1. In fact, I think it might be worthwhile to say that. It's even good to label it. This is great studentship right here. x1, y1. This is x2, y2. Because often one thing that students do, one mistake that students make is they confuse which one should go where. Sometimes they put the x's in the top, and sometimes they confuse exactly which one is x1 and x2. You don't want to do that. If you label these, then you're much more likely to get it right. So these are now labeled, and that's great. So the formula says y2, which is 2.38, minus y1 over here, all over x2 minus x1. Notice, y's are in the top. Yay! X is in the bottom. Yay! That's great. And now you can pull out your calculators and divide this number by this number. And if you're going to type it in, make sure you use parentheses. Parentheses 2.38 minus 1.31, close parentheses, divided by another set of parentheses. And then you hit enter once and you get this. That's billion smartphone users per year. We get the y-intercept because it's already given right here. The y-intercept is the value of the y when x is equal to 0. So we can just, calculating y-intercept is actually as simple as recognizing that this will be the y-intercept and just writing it down here. So if you're going to write an equation, you could say y equals the slope x plus 1.31. And then if you're going to figure out what the number of users in 2025, then you take the x value of 12, you can put it into the equation here, and it looks like this. Calculate it all out, and you get 4.52 billion smartphone users in 2025. I wouldn't be surprised if we got that already. Let's do example number 5. Write the equation of a line that passes through 3 comma negative 5 and has a slope of 11 in point slope form. Okay, so what do we know? We know the slope is equal to 11. We know that x1 over here is 3. We know that y1 is negative 5. So we can use our formula right here. Y minus y1 is equal to m times x minus x1. So we're going to take that slope of 11 and put it in here, and then we take y1, put it in here, and x1, put it here. And that's actually point slope form. We've satisfied the instructions right here with this second line. That's the answer. I want to take it a step further and show you what it would look like to put it in slope intercept form. And you keep on going. You can change this minus and negatives to just plus, distribute the 11, and then you can get y all by itself by undoing this plus 5. So subtract 5 from both sides. And I want you to figure out what would go here. All right. Let's keep moving along. Example 6. Write an equation of a line that passes through 1, 1 and 7, 3 in point slope form. Knowns. So this is, what do we know? We know x1 is 1. We know y1 is 1. We know x2 is 7. We know y2 is 13. It's kind of good to label these. You could also, if you didn't want to write all that out, you could just label it right here. x1, y1, x2, y2. So that it's a lot easier to plug them in the right place, and you're less likely to make a studentship mistake. We make sure we get those y values in the top and x values in the bottom. Don't flip them. Don't put them in the wrong place. Put those y values in the top. And so we get 12 over 6, which is 2. The slope is 2. The easiest equation to plug this into would be this one right here, point slope form. And so then I could just choose x1 to be 1, y1 to be 1, and the slope is 2. And actually here, this line satisfies everything. We don't really need the rest, but I just wanted to show you what it looks like to put it in slope-intercept form. You just distribute and then add 1. Example 7, architecture. The Tower of Pisa began tilting during its construction in 1178 and continued to move until a restoration effort reduced the lean and stabilized the structure. Glad they did that. Wouldn't want it to fall over. The Tower of Pisa leaned 5.4 meters in 1993 compared to a lean of just 1.4 meters in 1350. Write an equation in points. So the 1993 was the when the restoration effort began. So you can see it went from 1350, 1.4 meters. It got really bad, 5.4 meters by the time they started restoring it. Write an equation in point slope form that represents the lean y in meters of the Tower of Pisa x years after its construction, 1178. All right, so here's what we don't know. We don't know x, we don't know y, but it's very important to write it down and make sure we're clear about things. X is years after 1178, and then y is lean in meters. So that the knowns, 1993, the date the restoration started, minus the years after 1178, so that would be 815. Subtract 1178 again here, that's 172. So we know that 172 years after it was constructed, it already had a lean of 1.4 meters, and then 815 years later, by the time the date restoration started, the problem got as bad as 5.4 meter lean. That thing's about to fall over. Glad they fixed it. So the slope would be y2 minus y1 over x2 minus x1. This is y2. So you got to resist the temptation to put the bigger numbers in the top. You might be like, oh, 850, like you might just be used to putting really large numbers in the numerator and the small numbers in the denominator. But because we have examined the units and because we have labeled things, we know this is y2 minus y1, and this is x2 minus x1. Y2, sorry, this is y2 and this is y1, and this is x2 and this is x1. We know that the lean in meters has got to go in the numerator. We know that the years has got to go in the denominator. Even though it'll give us a really, really small decimal, that's okay. We expect one. We're expecting a very tiny meter per year answer. So this is 4 divided by 643, and that's approximately 0.0245 meters per year, or 2.5 centimeters every year, which is tiny, but it adds up over the centuries. Write an equation in point slope form, and that would look like this. Y minus y1 is equal to m times x minus x1. Slope, and then the point 172, which is x1, and then y1 is 1.4. That, my friends, is the video for today. Thanks for paying attention. Thanks for playing along at home. Y'all are winners. Can't wait to see you in class. Take care.